Welcome back to our introductory course on data visualization. In this class, we are going to focus on visuals that allow us to divide the data into parts proportionally to their contribution to a whole. Examples of methods to be presented here include pie charts, donut charts, and tree maps. Let's talk now about proportions, visuals that allow us to plot or to observe proportions. In this case, we have pie charts, the donut chart, and tree maps. The idea is to explore and visualize the distribution of a variable that can be divided into a small number of different and mutually exclusive categories, where each category is a fraction or a slice of the whole. And that's a key aspect here because all three of them, the pie chart, the donut chart, and the tree map, they have the concept of a whole, which is a shape. And this shape can be a pie, a donut, or a rectangle. And the proportion of each value or each category of a variable will have to fill one part of this shape. And from this explanation, we can already see that this type of visual works with categorical data. Let's take the case of the mammographic data set. For the mammographic data set, we've seen that the shape or the margin in this case of the mammogram, it can have these 5 different values. It can be microlobulated, obscured, speculated, ill-defined, and circumscribed. So in this pie chart, we can see that here I also plot the percentage value of each of these slices. And it's very interesting because if we pay attention at it, if we remove these percentage values, we will have a lot of difficulties to identify what is the contribution of each of these categories for the variable margin. Because as humans, we are not very good at estimating the proportion of these slices based on their size. So the addition of the value here helps us a lot in this process. And this is the reason why I plot the bar chart here. And remember, this is a bar chart because this is a categorical variable. And so we can see that we can much better estimate the percentage value by looking at the bar chart than by looking at the pie chart without the values plot within the pie chart. This is the pie chart for the forest fires data set. And here I am presenting the number of objects. In this case, they are presented in percentage terms for each day of the week. As we can see, this distribution is much more uniform than the other one. Almost all days of the week appear here in between appear around 10%. Right, so the variation between them is small. So this is 10.4 for the Wednesdays, 11.8 for the Thursdays, 12.4 for the Tuesdays, and so on and so forth. And we can observe them here in this bar chart. The donut chart is very similar to the pie chart with the difference that you create a hole in the middle of the donut. And this hole can have any diameter that you want. This is usually a parameter that you set in the tool that you're using. So as you can see, here I've got a smaller hole. Here I've got a bigger hole. This is for variable margin. This is for variable day. In this case, I chose to plot the percentage values inside the donut. In this case, I decided to plot them within the donut. But these are usually parameters that you define when you're using your tool. The goal of the tree map is to explore and to visualize hierarchical data in nested and mutually exclusive rectangles. Well, one important thing is that the data doesn't need to be hierarchical for us to use a tree map. But if it is hierarchical, then the tree map is a very interesting tool because it allows us to see the different layers and what we have within each layer of hierarchy in the data. So it's very common to use them with data that present a hierarchical structure and categories that can be divided into subcategories. For example, continents, countries, states, cities, and things like that. So the interpretation, each rectangle represents a category within the whole, and the larger the rectangle, the greater its value or its proportion. In this first example, I am showing again the mammographic dataset, the margin variable, and here we have the tree map. As we can see, in this tree map, we have no hierarchy between the categories: microlobulated, ill-defined, circumscribed, speculated, and obscure. They're all mutually exclusive. For the variable day of the forest fires dataset, the same thing. The categories are mutually exclusive. But if we look now at the Gapminder dataset, and we are looking at variable GDP, the gross domestic product by country and continent, here I am showing only the values that are greater than 5%, because otherwise we would have some very small rectangles and subdivisions here. And I didn't want to make this graph too cluttered. So we can see here South America in blue, North America in green, Asia in purple, Oceania in red, Africa in orange, and Europe in cyan. And within each of these continents, we have some countries, those that contribute to more than 5% of the GDP of the whole continent. And I also plot here the value of the GDP in this case in percentage terms for the continent for each of the countries that I'm showing here. In this case, we can see that the hierarchy is very well defined for each of the subcategories that are represented here by the different colors and the larger rectangles. Thank you for watching, and see you in our next class. Do not forget to subscribe and look at the other courses and series available in the channel.